So here are some of our polynomials right here. Don't write this down. I'm just kind of introducing something to you guys. These A's right here, these just represent numbers. A sub 1, A naught. There's A naught right here. This would be a constant function. This one right here would be a linear. This one right here would be a quadratic because it has a 2 for an exponent on one of the variables, on the independent variable, which would be your x. And this one right here, this would be a cubic function.
What is that?
The cubic one is more like an n. I call it an n, but some people have a hard time seeing it. It looks like this. You're like, what? That doesn't look like an n. Sometimes though, if you manipulate a little bit, it'll start looking like this, and that looks like an n to me. So, but we're not gonna get into that. Normally, when you guys see a quadratic, you see it like this. You don't see it with the a's. You see one a, and then there'll be a b right here, and there'll be a c right here. You guys remember that? I call that standard form. But anyways, I just want to point this out to you guys to show you guys. We're gonna look at quadratics today. I call this standard form, and this is another way to look at it. F of x equals ax squared plus bx plus c. Every textbook that I've ever seen and everything that I've learned, this is standard form. This is the one textbook that doesn't call this standard form, which I thought was kind of weird. I always call this one right here Vertex form. The book calls this standard form. So whenever the book says standard form, know that it's talking about this one right here. It calls this standard form. That's not a big deal though. I don't really care if it calls it standard or vertex form. What I do care about though is when you want it to look like this and when do you want it to look like this. Tonight for your practice, you want it to look like this. And so that's what we're going to work on right now. Oh, my voice is gone now because of that birthday song. All right. The H and the K are special here. The H and the K are actually always going to be your vertex. I mean, they're the coordinates for your vertex of your parabola. And when you guys look at parabolas, your vertex is always that point right in the middle. And your parabola can face up like that or down like this. And the A is what decides if it goes up or if it goes down. If it's positive, if it's a positive A, then it's going to go up. If it's a negative A, then it's going to go down. Now both the H and the K and the A all affect the quadratic. If you guys remember, some of you guys might remember the common function. Some people call them the parent function, x squared. So the A, the H, and the K, they change the x squared function. The H moves it left and right. You always got to think the opposite though. Whenever something happens to your independent variable, which in this case is the x, the independent variable is always the domain when you come to functions. You think the opposite. So if the inside said x minus 3, then you got to think, okay, it moves to the right 3 instead of moving to the left. The K is not so. The K is normal. You think about him normally. He moves them up or down, changes the y values. The A stretches it. It stretches your function. Now it can stretch it two ways. It can stretch it horizontally or it can stretch it vertically. Two ways. It'll stretch it horizontally if the number is less than 0. No, I'm sorry, greater than 0 but less than 1. So if it's a fraction, pretty much, you can say if it's a fraction. If you're not understanding this, the x would have to be greater than 0 and less than 1 in order for it to stretch horizontally. To stretch vertically, it just has to be a number greater than 1. Okay. So let's look at these first two examples. Now, in my first period class, I tried to do it a different way. It didn't work out. And so I tried to do a hard one first and then an easy one. But we're going to start with the easy first. So here we have two functions. We're going to start with this one. This function is not in vertex form. I'm going to call it vertex form, but it's standard form in the book. Okay. This one is not in vertex form. So we're going to change this into vertex form. And there's ways to do it. It's manipulation. Okay, we're going to manipulate this a little bit. So stay with me. The first thing you do is you group the x terms together. You kind of push out the -3. He's going to be by himself. And so we have our x terms right here, x squared minus 2x. Give yourself a little space, put the parenthesis there, -3. Now the space is important because what we're going to do is we're going to add a number to that so that it's a perfect square. Now let me talk about perfect squares for a minute, just because I don't think that everybody understands them extremely well yet. Now you guys know that vertex form looks like this. We'll say the vertex form is a x minus h squared plus k. So this right here, that's a perfect square trinomial. If I take, let's say x plus 5, and I square that, that would be x plus 5 times x plus 5, and then when I multiply it all out, I'm going to get x squared plus 10x plus 25. This 25, or this polynomial right here, that's a perfect square trinomial. And whenever you have a perfect square trinomial, you can write it, when you factor it, you will write it like this. Now this is what we want for our vertex form. So how do we get that with this? Well, we do some manipulating. We look at the x squared and the minus 2x, and then we add something to it to make it a perfect square, just like this one. Do you guys know what I would have to add to this to make it a perfect square? It would be a 4. Okay? Now this is how you find out. This is how you find it. You take b, which is this guy with the x term. You take b. I want to write that in blue. No, I want to write it in red. You take b and you divide it by 2, and then you square it. That's kind of like this thing right here is what you use to complete the square. So the other thing that's kind of different is, since we're manipulating it, I'm just going to move this guy up here. I'm going to manipulating it. Whatever we add to that side, we have to take it away too. Because if we don't take it away, then it's changed. It's different. And so, let's see, this is f of x. If we add something to this, we have to take it away so that it stays the same. So I'm going to put minus the same thing right there. So you guys said I would add 4. Yeah. So I put a 4 right here. That means you have to take it back away so that it stays the same. It doesn't actually change. Now, we just got to simplify or factor this right here. So when I factor that, that would be the shortcut, guys, to factoring. Here, look down here really quick. Look at the bottom again. If I was to factor this, instead of having to do the big X and everything, because I know it's a perfect square, I can take the square root of that and take the square root of that. The square root of x squared is x, and the square root of 25 is 5, and that's how I get those. This is plus, and so this is plus. So up here, the square root of this is x. And what's the square root of that? 2. So I have x and 2. Is it minus or plus?
Minus.
Minus because of this guy. Alright, now I have -3 minus 4. That's going to be -7. And there you have vertex form.
That's the wrong square.
That's the wrong...
Should be 4.
Hold on.
It should be 1.
Sorry, guys. I was so caught up in my explanation. Thank you guys for correcting me on that. This should be a 1. You're like, wait a second. 2 divided by 2 is 1, and then you square it, so that should be a 1. And that's going to change some other things. That's not going to be a 4 anymore. That's not going to be a 7. That's not going to be a 2. Okay, so let's fix those. This will be a 1. And this would be, some people are still asking, wait, why can't it be 2? -3 minus 1 is going to be -4. Okay, that's it. I'm going to give you a second to type that in. Press pause. I just realized that this should not say just vertex. This should say vertex form right here. That's what we're doing. And down here is vertex form. So really quickly, let's identify some things. What is my a in this function? It is 1. What is my h? No, it's not -1. It's +1 because vertex form says minus h. So that's a +1. And then what's my k? That one is -4. Okay, so our vertex would be 1, -4. And because the A is 1, I don't have to worry about him. He's not going to stretch my graph at all.
But if it were to be
Now, guys, this is the basic one. Okay? There's other dudes like this guy that require a little bit more work. This one has an A besides 1. So make sure you guys understand this. Ask me any questions right now before we go into this one because it's going to get a little hairy.